Trigonometry 1. A man walks directly from a point A toward the foot of a tall building 240 meters away. After covering a distance of 180 meters, he observed the angle of elevation of the top of the building is 45 degrees. Determine the angle of elevation of the top of the building from N. Now I've sketched a diagram there to illustrate the question. You can see from the building to point A is 240 meters, and then the distance the man has walked 180 meters. He is here to walk 60 meters, and from that point the angle of elevation is 45 degrees. Now we know that tan theta is equal to the opposite side of the adjacent side. Tan theta is 45 degrees. The opposite side, the building, we don't know, and we know the adjacent side distance from the building to where the man is 60 meters. Now the opposite side, or the height of the building, if we solve that, it becomes 60 meters. Now you can still get the angle of elevation from point A, the building, using tan theta. Now the building, we have gotten it to be 60 meters. The adjacent side is 240 meters. So 60 over 240, we get tan theta as 0.25. Now looking at our tables, or using a scientific calculator to find what tan theta 0.5 is, we find it to be 14.04 degrees. A point A is directly below a window. Another point B is 15 meters from A and at the same horizontal level. From point B, the angle of elevation of the bottom of the window is 30 degrees, and the angle of elevation of the top of the window is 35 degrees. Calculate the vertical distance from A to the top of the window. Then also calculate the vertical distance from A to the bottom of the window. Also calculate the vertical distance from the bottom to the top of the window. Now we tackle the first part, the vertical distance from A to the window. You can see I've sketched the diagram. That means from point A to the top of the window, we can use the tan theta to calculate that. Tan theta, we know, is the opposite side over the adjacent side. Now our opposite side is AT, our adjacent side is AB, which is 15 meters, and tan theta is 35. Now forming that equation, you can see that AT becomes 10.53 meters. Now the other part, we have to calculate the distance AM, or the distance from A to the bottom of the window. You can see by the sketch. You can still use tan theta to calculate that, having that angle of elevation 30, and we know the distance is 15. So AM becomes 8.661 meters. Now what about TM? We have gotten the distance AT and AM. So MT, or TM for that matter, is not hard to calculate. We just subtract the two, the distance AT and AM. AT was 10.503 meters, AM was 8.661 meters. So subtracting it, TM as 1.84 meters. In the figure below, angle ABC is 30 degrees. Angle ACB is equals to angle ADC, which is called 90 degrees. AD is equals to 4 all over 4 times the square root of 3 centimeters, and DC is 4 centimeters. Calculate the angle AC. Sorry, calculate the length of AC, not angle. Calculate the length of AC and also calculate the length of BC. Now AC, we can calculate it using a number of ways. First, let us get tan theta. Tan theta is CD over AD. This is equivalent to 4/3 times the square root of 3. So tan theta is 1.7321, which is equivalent to 60 degrees. Now, having found tan theta, we know sin theta. Sin theta is CD over AC. So tan theta is 60. That is 4/AC. If we make AC the subject of a formula, it becomes 4/sin 60. Solving, we get that AC is 4.619 centimeter. Now we can move ahead to calculate BC. BC we can use tan 60. Remember that we have two angles of triangle ABC. One is 90, one is 30. So what is remaining is 60. That is 180 minus 90 minus 30 is remaining 60. So we can use the angle we have found, the remaining angles 60 as make it tan theta, so that we have BC over AC. We know AC, the BC there is the one we are calculating. Making BC the subject of the formula, we find that BC is equals to 4.619 multiplied by tan 60. Solving for BC, we find that BC is 8 centimeters. Two straight paths are perpendicular to each other at point P. One path meets a straight road at point A, while the other meets the same road at B. Given that PA is 50 meters while PB is 60 meters, calculate the obtuse angle by PB and the road. Now I have sketched the diagram and I have sketched the angle. We have to find the obtuse. I put a question mark then. Now we cannot find directly. What we need to do is to find our angle ABP. We have to find our angle ABP, and then subtracting from 180 we shall find that obtuse angle. This angle ABP can be found by taking tan theta AP over BP. AP is 50 meters, BP is 60 meters. So tan theta becomes 0.83333. Looking at our mathematical tables or using scientific calculator, tan theta 0.833 is equivalent to 39.8 degrees. So our obtuse angle will be 180 minus 39.8 degrees, which becomes 140.2 degrees. Given that sine 90 minus x is equal to 0.8, where x is an acute angle, find without using mathematical tables the value of tan x. Now you can appreciate this question very well if we use a diagram. Look at the diagram I have sketched below. It's a right angle triangle. Now for sine 90 minus x to be 0.8, It means that one side is 8 and another side is 10. You know that sine theta is the opposite side divided by the hypotenuse. So the opposite side must be 8, the hypotenuse must be 10 to get 0.8. Now I've sketched, look at sine 90 minus x. The opposite side is 8, the hypotenuse is 9. Now we know for a right angle triangle, one angle, the other two angles apart from the 90 should also add up to 90. So you have been given an angle 90 minus x. It means that the other angle must be x. So that when you subtract 90 from the other angle, or when you add the two angles, you get 90. So I've labeled, you can see the angle I've labeled x. Now we are told to find tan x. So tan x will be the opposite side over the adjacent. Now we know the adjacent side to be 8. We don't know the opposite side, but we can find the opposite side using the Pythagoras theorem because we know the hypotenuse. So it will be the hypotenuse squared less the side we have been given squared, and then find the square root. So tan x will be the square root of 10 squared minus 8 squared all over 8. Solving for that, we get that tan x is 3/4. The diagram below represents a school gate with double shutters. The shutters are each opened through an angle of 63 degrees. The edges of the gate PQ and RS are each 1.8 meters. Calculate the shortest distance QS correct to 4 significant figures. Now we know the length QS is equals to the length PR minus 2 hypotenuse cos theta. Now QS is equals to length PR. Length PR is 2 multiplied by 1.8. That's just the length of the gate. Now the gates are 2 and each gate is 1.8 meters. So if you multiply 2, you get that length. Then less 2 into 1.8 multiplied by cos theta 63. What it means, we are trying to find the distance of how the gate have moved from PR. If we find the distance, then subtracting from the length of the gate, we get QS. Now we go, we simplify, we find that length PR is 3.6 meters, and then 2 hypotenuse, 2 multiplied by hypotenuse is now 1.8, the length of one gate, and then multiplied by cos 63 to find now how wide the gates have opened. Now solving, you get that QS is 1.9656, and writing to 4 significant figures 1.9666. Given that x is an acute angle and cos x is equals to 2 multiplied by the square root of 5 all over 5, find without using mathematical tables or a calculator tan 90 minus x. Now we know cos x. Cos x is the adjacent side all over the hypotenuse. Now I've sketched the triangle, a right angle triangle, and we have x. So if we take cos x, our adjacent side will be 2 multiplied by the square root of 5, and the hypotenuse will be 5. Now we know that for a right angle triangle, the two remaining angles must add up to 90. So we have been given cos x, or now the angle x degrees. To arrive at 90, the other remaining angle should be 90 minus x. So you can see I have illustrated there. The two remaining angles should add up to 90 degrees. Now, having been given one as x degrees, the other one should be 90 minus x. And that's the angle now we shall concentrate, because we have been asked to find cos 90 minus x. Now, being at 90 minus x, you can see that the opposite side to that angle is 2 multiplied by the square root of 5. The adjacent angle is, we have not been given, but using Pythagoras theorem we can solve it. It is squaring the hypotenuse, then less the square of the angle you have been given, and the whole result, we find the square root of the results. You can see I will illustrated there on the angle. Now, let's do the math now. Tan 90 minus x is equals to 2 multiplied by the square root of 5 all over 5 squared minus 2 multiplied by the square root of 5 squared, and then the result of that we get the square root. So if we simplify, we find that tan 90 minus x is equals to 2. Points L and M are equidistant from another point K. The bearing of L from K is 330 degrees. The bearing of M from K is 220 degrees. Calculate the bearing of M from L. Now I have sketched the diagram to show where L is and where M is. I have shown now the bearings. Now, as per the diagram, the bearing of M from L, look at where M is and where L is. It will be just a matter of adding the 90 degrees and adding 60 degrees. That's L from K. L from K is 90 and 60, and then adding the 35 inside the triangle, and then we get the bearing is 185. If you sketch and then follow those bearings you have been given, you just find the angles as I have found inside the triangle. You can see the first angle is 60, and then 50, so it becomes 110, and then that other one at M is 35. The other one is also 35. I've gotten those 35 because we have been told M and point M and L are equidistant from K. So having gotten that angle at N, which is 110, the others are base angles of isosceles triangle. So you just subtract 110 from 180 and then divide by 2 to get those base angles of an isosceles triangle as 35 degrees, 35 degrees. The diagram below represents two vertical watchtowers A, B, and C, D on a level ground. PQ are 2 points on a straight line, on a straight road BD. The height of the tower AB is 20 and the road BD is 200 meters. A car moves from B towards D. At a point P, the angle of depression of the car from the point A is 11.3. Calculate the distance of BP to four significant figures. If the car takes 5 seconds to move from P to Q at an average speed of 36 km per hour, calculate the angle of depression of Q from A to Z. Q from A to two decimal places C. Given that QC is equals to 50.9, calculate the height of CD in meters to two decimal places. The angle of elevation of AC from C to the nearest degree. Now we have been given the diagram. You can see tower A, tower C. One thing we must notice that the angle of elevation and the angle of depression are always the same. Now, if we have the angle of elevation to be 11 point, of depression to be 11.3, the angle of elevation should also be 11.3. Now, the first thing you have been told to calculate BP. BP can be taken as tan theta, and tan theta you take that distance BP all over the height of the tower AB. Now tan theta, how do we get it? We subtract 11.3 from 19, so we get that tan theta is 78.7. AB we know it is 20 meters. That's the height of the tower. So we have to calculate the distance of the road BP. So making BP the subject of the formula, it will be 20 meters multiplied by tan theta 78.7. We get BP as 100.09 meters. Now writing that to four significant figures, it will be 100.1 meters. Now part B, you have been told to calculate the distance PQ. Now we know that distance is equal to speed times time. Now we have been given the speed of the vehicle is 36 km per hour. Change that into meters per second. It will be divided by a factor 3.6. It will change that 36 km per hour to be meters per second, and then multiply by the 5 seconds the car took. You find that the distance PQ is 50 meters. Now the distance BQ will be the distance BP plus the distance PQ. We have found BP to be 100.1 and PQ to be 50. So the distance BQ will be 150.1 meters. Now let's take this tan theta AB over BQ. So tan theta AB over BQ, we have found, we have been given AB as 20. We have found BQ as 150.01. So tan theta becomes 0.1332. Now look at the tables of using a scientific calculator, you find that tan theta is 7.59. That's the angle we have been asked to find. It is 7.59 degrees. Now let's look at part C. We have to calculate the height of CD as part 1 of C, and also the angle of elevation of AC as part 2 of C. Now we know something. The distance from B to D is 200, and we know we have our distance from B to Q to be 150.1. So subtracting, what is remaining is QD. QD becomes 49.9 meters. Using the cosine rule, we have the adjacent side over the hypotenuse. So the adjacent side we have found up as 49.9 meters. The hypotenuse for that relevant distance is 50.9. So we get our cos theta to be 11.38 degrees. Now CD we shall take 49.9 meters multiplied by tan theta, which we have found it to be 11.38 using cos theta. So CD becomes, that tower CD becomes 10.04 meters tall. Now the angle of elevation. The angle of elevation, we shall take tan theta, which is 9.96 meters over 200 meters. So tan theta becomes 0.0498. Looking at our tables or scientific calculator, 0.0498 is the same as 3 degrees to the nearest degree. In the diagram below, PA represents an electricity post of height 9.6 meters. QB and RC represents two-story buildings of height 15.4 meters and 33.4 meters respectively. The angle of depression of A from B is 5.5, while the angle of elevation from C from B is 30.5 degrees, and BC is 35 meters. A, calculate the nearest to the nearest meter the distance AB. B, by scale drawing, find the distance. Find 1, the distance AC in meters. B, the angle BCA, and hence determine the angle of depression of A from C. Now, if you draw the diagram to scale, factoring everything you have been given, you will find that AB is 61 meters, and the distance AC is 94 meters, and the angle BCA is 16 meters. An electric pole is supported to stand vertically on a level ground by a straight wire. The wire is pegged at a distance of 6 meters from the foot of the pole as shown. The angle which the wire makes in the ground is 3 times the angle it makes in the pole. Calculate the length of the wire to the nearest centimeter. Now, if we sketch that diagram the way I've been told, you can see the pole, the wire, and the angle it makes with the ground, and the length. Now, what it means is that we have a right angle triangle, and a right angle triangle, the other two angles must add up to 90. So this means that 3x plus x is equals to 90 degrees. 4x is equals to 90 degrees, and now what is x? X is 22.5 degrees. Now what is 3x? 3x is 67.5 degrees. Now we can use the cosine rule to find the length of the wire. The length of the wire is 6 meters all over cos 67.5. So solving, we get the wire is 15.6 meters, which is equivalent to 157 centimeters, the nearest centimeter. Given that 3 theta is an acute angle and sine 3 theta is equals to cos 2 theta, find the value of theta. Now sine theta, we have been told, is equals to cos theta. Now we know if sine 3 theta is equals to cos 2 theta, then sine 90 degrees minus 2 theta is equals to cos 2 theta. So having equated that, sine 3 theta is equals to sine 90 degrees minus 2 theta, we drop the signs and solve. So we get that theta is equals to 18 degrees. Given that sine x plus 60 is equals to cos 2x, find tan x plus 60. Now we know that sine x plus 60, if it is equal to cos 2x, then it is equals to sine 90 degrees minus 2x. Now we have equated signs on both sides of the equation, so we drop the signs and solve for x. So x is 10 degrees. Now if x is 10 degrees, tan x plus 60 is equivalent to taking x plus 60. X we know is 10, so 10 plus 60 is 70, and tan 70 is equivalent to 2.7475, which we can write as 2.74824 significant figures. Given that tan x is 3/7, find cos 90 minus x, giving your answer to 4 significant figures. Now, I have not sketched a triangle there, but know something that tan x or tan theta should be equal to the opposite side over adjacent side. Now, if tan x is equal to 3/7, it means that the opposite side is 3, the adjacent side is 7. Now, what will be the hypotenuse? The hypotenuse will just be equal to the square of 3 plus 7, and then get the square root of the results. So cos x should be equal to the adjacent side, which is 3, and the hypotenuse, which is 3 squared plus 7 squared, and then finding the square root of the results, which gives us 0.9191. Looking at the tables or the mathematical or the scientific calculator, we get x to be 23.1986 degrees. Now cos 90 minus x, it means we have to subtract x from 90. So our x is 23.1 degrees. So subtract it from 90, we get that cos 90 minus x is 66.8 degrees. Now get that cosine from the mathematical tables or scientific calculator. You get that cos 90 minus x is 0.3939. A piece of wire is bent into the shape of an isosceles triangle. The base angles are 48 degrees and the perpendicular height to the base is 6 centimeters. Calculate the correct one decimal place the length of the wire. Now if we take tan 48 is equal to 6 over the adjacent side, we find that the adjacent side is 5.4 centimeters. Now the adjacent side is half the base. Now let's look at sine theta. Sine theta we shall get it by taking the adjacent side over the hypotenuse. Now the hypotenuse making the subject of the formula, because we have the adjacent side and sine 48 degrees, the hypotenuse becomes 1.8 centimeter. Now the hypotenuse are 2, because those are the equal sides of that isosceles triangle, and the base we had gotten it half of it using a tan theta or tan 48. So the base 5.4 multiplied by 2, you get 10.8, and then the hypotenuse which are 2 8.1 multiplied by 2 gets 16.2. So the length of the wire is 10.8 plus 16.2, which is equals to 27 centimeters. Solve the equation sine 1 over 2x minus 30 is equals to cos x for values between 0 for values between x is less than 0 and x is less than 90. Sorry, x is greater than 0 and x is less than 90. Now we know sine half x minus 30 being equal to cos x. It just means sine half x minus 30 is equal to sine 90 minus x. Now I have equated the signs on both sides. We drop the signs and then solve for x. So a half minus 30 is equal to 90 minus x. X is equal to 80 degrees. Given that sine 2x is equal to cos 3x minus 90, find tan x to correct 4 significant figures. Sine 2x being equal to cos 3x minus 10 is the same as sine 2x being equal to sine 90 minus 3x minus 10. Now having equated signs on both sides, we drop the signs and solve for x. X becomes 20 degrees. Tan x will mean that tan x is equals to 20 degrees. And tan 20 degrees from the tables or using a scientific calculator is 0.3640. Given that sine theta plus 30 is equals to cos 2 theta, find the value of cos theta plus 40. Sin theta plus 30 equal to cos theta, cos 2 theta is the same as saying sin theta plus 30 is equal to sin 90 minus 2 theta. Now drop the signs and solve for theta. Theta becomes 20 degrees. Now cos theta plus 40 means we have 20 degrees plus 40 degrees, that is 60, and cos 60 degrees is 0.5. A vertical electric pole was erected 6.4 meters from the foot of a vertical fencing pole on the same horizontal level. The fencing pole is 2 meters high. The angle of elevation of the top of the electric pole from the top of the fencing pole is 30 degrees. Determine the height of the electric pole correct to 1 decimal place. Now, the height of the pole, electric pole, remember vertically from the fencing pole, which is 2 meters high. So that part, the lower part we have found is 2 meters high. Now we have to find the other part from which we have the angle of elevation, 30 degrees from the top of the fencing pole. Now that means we shall use the sign, because we have the adjacent side as 6.4 meters. Now multiply that by the sin 30, which is equal to 0.5. And add the 2 meters of the fencing pole. We get that the electricity pole is 5.2 meters. Solve for theta. Sin 2 theta minus 11 is equal to cos 3 theta. This is similar to saying sin 2 theta plus 15 is equal to sin, sorry for that mix up, it should be sin 2 theta minus 15 is equal to sin 90 minus theta. Then solving for theta, you get it to be 21 degrees. Please ignore the addition sign I put there. They should be minus. An electric post erected vertically is 20 meters from point P on the same level ground. The angle of elevation of the top T of the post is 30 degrees. Given that S is the midpoint of the post, calculate correct to 1 decimal place the angle of elevation of S from P. Now, first of all, we shall use the tan to find the distance AP. Having found that, we shall still use the tan to find the angle of elevation, and which is 16.1 degrees to 1 decimal. Solve the equation. Cos 2 theta is equal to sin theta for values between 0 c pi c over 4. Leave the answer in terms of pi c. Now that's self-explanatory. We have done that in the previous sum. I think you should be able to get it now. But solve, you should get it as pi over 12. We have tried to leave it in radians. So that is the answer. From a point on top of a cliff 40 meters high, two boats A and B are observed due east. The angle of depression of the boat A is 32, and that of B is 52. Determine the distance between the two boats correct to two decimal places. Now that's self-explanatory. You can use the turn rule all through, and you can say I've gotten them. Try to appreciate all the to embrace them in your mind. P, Q, and R are points on a level ground. Q is 4.5 meters south of P. R is to the east of P and is 5.3 meters from Q. A vertical post at P is supported by a cable of length 3.5 meters. The cable joins the top of the post to point R. Calculate the angle between the cable and the level ground. Correct two decimal places. Now here you can just draw a right angle triangle and appreciate what we have been taught them, and following my working you will get the angle to be 36.87 degrees.